Alright, let's take a look at this daily lead code question. It's in video 1 called as count total number of colored cells. There exists an infinitely large two-dimensional grid of uncolored unit cells. We are given a positive integer n, indicating that you must do the following routine for n minutes. At the first minute, color any arbitrary unit cell blue. Every minute thereafter, color blue every uncolored cell that touches a blue cell. Okay, so we will be given a square here. Okay, uh, according to the n number. Okay, so input 1 will be this. Now what we'll do, we will color the edges of this square. For n is equal to 1, we will color this this edges, this edge, this edge, and this edge. For n equals to 2 input like this, what we will do, we'll color this cell, this cell, this cell, and this cell. And for n equal to 3, we will do like this. All right. So constant is 1 to 10 to the power 5, and we can look at the hint here. Derive a mathematical relation between total number of colored cell and time elapsed in minutes. So it's a kind of reasoning type question. We will use arithmetic series. We will find the series that will give us number of these colored cells according to the input number n.
Alright, let's take a look at the example that was given the problem. Firstly, we get n equals to 1. I am taking 3 examples here. N equals to 2 and n equals to 3. Okay. So for n equals to 1, we will be given a single square here that will be filled with blue color. Okay. Now for second iteration, we will take this as second example here. Now this square will be taken to its next iteration. This was the input. Now we will fill the edges of the square again like this. Okay. Okay, we got our output here as 5, as 5 squares are filled. Here only 1 square was filled, so we will simply get output of 1. Okay, now we'll take this condition again in the next example. Like this. Okay. Okay, let's start with filling the colors. So we will start with our first square. This will have 4 edges. Okay, like this. Okay, this edge is already filled, so we will skip this in our code. So I'm marking this with red color. Now we'll move to our second square. So it will have again 4 edges, like this here, this here, this here, and this third square, but it is already filled, so we'll just mark this. Okay. Now we'll move to our fourth square. So this will again have 4 edges. This third square is already filled, so we get our last edge here. So we'll also mark this with a different color. Okay, for our last square, that is 5, again we will mark this with different color. So 3 is already filled. Okay, this is already filled, this is already filled, so we got our last square here, and we will fill this. Okay, so how many filled squares we got? 1 2 3 4 5 6, 7, 8, 9, 10, 11, 12, and 13. So our output will be 13. Okay, let's take n equals to 4 also here. Okay. Again, we'll mark the colors of the edges here. Okay, for this square also, what we got, it is this will be filled. All other are already filled. For this square, we also will get this. Let's fill this. For this square, we will do like this and fill this also. Okay. For this square, we will also fill like this. Okay. So for this square, we will fill like this. We will count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. So we got our output as 25 here. So now we can see the pattern here. For n equals to 1, we got output as 1. For n equals to 2, we got 5. For n equals to 3, we got 13. And n equals to 4. So now we can find a difference in this sequence here: 4, 8, and 12. Okay, so again we can find difference here: 4 and 4. So we can now make a guess that the sequence is increasing with 4 increments here. So we can write this as 1 plus 4 plus 8 plus 12 plus this will go on like this till nth term. Okay, so we can also write this as 1 plus 4, 1 plus 2 plus 3 plus 1 term. We can simply put a formula here: n minus 1 by 2. It is basically sum of natural numbers till n. Okay, it's a basic math formula. So this is how we will code our algorithm here.
Let's start with the code part now. We'll define a count variable. We'll take this as long because the constraint is a little large, 10 to the power 5. So long count is 1. Now we'll take a name, mark here as 4, because every square will have 4 edges. It will be colored on its 4 edges. So we'll take 4 here. So now we'll start our loop here. While n is greater than 1, we'll increase our count to our mark. Okay. So now our mark will be, we'll increment this with 4 and we'll decrease our plus n, right? N. Okay. We will now return this, return our count. This was the difference that we got in a sequence. Let's try to run it. We can now submit it.